So he began to accelerate from rest. Does that happen at a specific place and time? Ask yourself. And if it doesn't, it's not an event. He began to accelerate from rest. What marks the end of that interval? Let's read it. He accelerated from rest to a maximum speed of 1,017 kilometers an hour. So the end of that interval is he reached a speed of 1,017 kilometers per hour. That's the end of the interval. Makes some sense. So many people were marking that as being an event when actually it's two events. Okay, critical understanding is important here. Okay, now let's think about what happens next. He moved at his maximum speed over a distance of 200 meters. That event has that interval has two events related to it. So we need to figure out what the second one is. We know what the first one is. What's the first event of that interval? He reached a speed of 1,017 kilometers per hour. So now we need to think, what's the second event that relates to that interval? Well, it says, when coming to rest again, he experienced an acceleration of a magnitude of 445 meters per second squared. So there's an implication here that he moved at this maximum speed over a distance of 200 meters, and then what happened? He began to slow down. So event number 3 would be the end of this interval. And this interval ends when something changes. So he began to slow down. Does that make some sense, folks? Let's look at the language there. Began. Right? It marks a change when something happens, specific place and time. That's an event, and this is going to affect your notation later. So he began to slow down, and that's followed by he just comes to rest. Just comes to rest. So we see between these events, we have intervals. Intervals are framed by events. How many intervals do we have?
4.
How many intervals do we have? 3. 3 intervals. How many events do we have? 4, which just makes sense. Right? 1 to 2, 2 to 3, 3 to 4. Those are your intervals. Anyone need any clarification on that? So when you read it, if you're having trouble figuring out what's going on, that may be that your language is still developing, in which case there are supports available for that. Okay, if you're an English language learner, okay, we'll get some support in from Ms. Salye. She's the ESL lead at this school. Now the next thing that people are kind of struggling with a little bit is coordinate systems, and some people, this is exactly how I show it in the booklet. That's a coordinate system. This is the origin. Right? So this is x equals 0. That's where event 1 took place. Then he sped up for a period of time. Let's put event 2 here. And your drawings don't have to be great, okay? Mine certainly aren't. There's our rocket sled. Arrives at 2. Begins to slow down. This is going to be a short distance compared to this one. Let's think about what was going on. He was speeding up. For 200 meters, he stayed at the same speed. Then he began to slow down. And he slowed down with a huge acceleration. There's no way he sped up with an acceleration that was similar to 445 meters per second squared. This is a ridiculously high acceleration. One piece of information I want you to have in your head. When something falls down, it's accelerating at about 10 meters per second per second. This is about 40 times that. Okay? Could kill you. It didn't, because he survived.
No, 40 times gravity?
Yeah.
40 Gs.
Yeah. Almost 45 Gs.
Astronaut killed 9.
So that's a huge acceleration. There's no way he was accelerating forward anywhere near that. He might have been 3 or 4 Gs. So this is going to happen over a much shorter period. And that's my coordinate system. It has an arrow, it has an origin. Because the origin is going to relate to your motion graphs for your position graph. It has what you're calling positive. And I'm going to call this one forward. Okay? So once you've drawn that carefully and you're thinking about what's going on, we want to use clear notation. So I'm seeing some of you use V initial and V final multiple times. And for different intervals. What's V at the beginning? It's 0, right? So we're going to call that V1. What's V at event 2? We're going to call that, watch out, 1,017 kilometers an hour, which we will need to do a conversion with. Right, so I think it's 253.5 meters per second, something like that. There's a 258. 282.5. Okay. You would show me the conversion here, okay? But I'm just going to go quickly. Meters per second. What's V3? He's moving at the same speed over this interval. So it must also be 282.5 meters per second. And then finally V4 equals 0 meters per second. So notice, I'm not using initial and final anymore. I'm using event numbers. Why? Because I have multiple calculations. How am I going to know? V2 here is the final velocity for this interval, right? But V2 here for this interval is the initial velocity. So that's why I want you to use event numbers. Okay? Then what are we looking for? We're looking for the acceleration between 1 and 2. What's that? What notation should we use? A 1, 2 equals question mark. That's what we're looking for. Okay? That's clear notation. Do you know exactly what interval I'm talking about?
Yes.
Absolutely, too. I know A2, 3. Right? His velocity isn't changing in the second interval. What else do I know? A3, 4. Has to be negative. Why is it negative? The velocity is in the positive direction and he's slowing down. Therefore, it's negative. There's 2 parts to that. Okay, if you're not sure about that, look over speeding up and slowing down. So that's what I mean by clear notation. We good with that?
Yeah.
I don't want to see I's and F's anymore. Okay?
What if I wrote like VI12?
Yeah, I wrote you a comment about that. Yeah, I hate you, Peter. No, you're just making it messy for no reason. So it's a small thing, but you need to fix it. It's just makes it harder to follow, distracting. In other words, it's inconcise. Right? Clear, concise, complete, correct. Okay, moving on. Don't talk while I'm talking, Luke. Motion graphs. So now we want to think about what's happening with our motion graphs. Position time graph. Where am I starting? At the origin. Why? Because I've defined that as my starting point on my sketch. So I'm starting at the origin here. What's my speed at the origin? 0 meters per second. How do I show 0 meters per second on a position graph? The slope of the position graph needs to be 0. So I start. Now it's changing until event 2. So I'm speeding up. So this is event 1, this is event 2. Remember, this needs to be a parabola. Okay, you did all the work with parabolas in grade 10? Okay, this is part of a parabola. Here's the vertex. We're moving towards, so this is event 2. Now, between 2 and 3, the velocity stays the same, doesn't it? So how do we show that? Constant velocity shows up as linear. So I draw it with a ruler to show its straight line. So that's event 3. Begins to slow down. Now, position graph, if you're slowing down, what's happening to the slope? That's what you always ask. The slope is flattening. Right? So, and let's think about how quickly that's happening compared to, okay, this isn't perfectly to scale, but it's not bad. Does he ever go backwards? So some people drew graphs that went up and then came back down. That's like he was a yo-yo, right? That wasn't happening. He was always traveling in the plus x direction. Speed of 0 at each end. Slope. Now, velocity graph, what speed does he start at? 0 meters per second. So that's event 1. Now, these graphs are graphing the same motion at the same time. So event 2 should line up with that. So he's speeding up. How do we show that? We're going to have a linear. It's going to be linear, right? Constant change of velocity. Whoops. Look at that. I almost made the mistake. I didn't line up my 1 and 2. So 2 goes here. I'm going to put it here. The actual slope doesn't matter that much, but there is a slope that will matter in a moment. There's event 3. There's event 4. Back at rest. Let's stop and think about it. In this course, we will never have a curve on a velocity time graph. Why? What assumption do we always make? Acceleration is constant. Where is acceleration on here? It's the slope of this line. So here's a low acceleration. Here's a really high negative acceleration. A lower positive acceleration. So I'm looking for that understanding. Okay? Now we need to translate this to the acceleration graph. How does the acceleration from 1 to 2 compare to the acceleration from 3 to 4? This one is a lower slope. There's a slope of 0 here, which means no acceleration, and a steeper slope. So how am I going to show that? Well, let me mark my spots. This is a lower acceleration, and it's positive. I know it's positive because, whoops. I know it's positive because, what's the slope here? It's positive. And the slope represents the acceleration. So make those connections. These things are all related to each other. From 2 to 3, where is my line? Now, 2, so it's here on the line. Kind of to show that, I'm just going to put some hash marks because it's hard to see the line. Okay, I'm not super picky about it, but there's no acceleration. And then from 3 to 4, there's a really large acceleration that's negative. And you could put 4 down here if you wanted. At the very end, the acceleration stops. But it's not that important. You can draw these dashed lines if you wish. Some people like to draw them. I'm not that picky about them. Notice. Right? And if you really know what you're doing, this area should be equal to this area. What's the reason for that? Well, this area represents the change in velocity. Remember how this area represents the change in position. So this area represents the change in velocity. There's more to learn. So that's what your motion graphs should have looked like for this. And a number of you got it, which is good. And so that's what we're looking for in terms of the motion graphs. And everything needs to match with your original coordinate system. So I started at the origin here means my position, sorry, I'm pointing to something you can't see. I started at the origin here means I start at the origin here. My initial velocity is 0 here. Means I show initial velocity 0 here with a slope of 0. Does that make some sense, folks? Any particular questions at this point? Okay, that's what I said I would cover today in today's seminar. I recorded it. I will make it available.